Hello and welcome to Differential Equations section 1.5 on linear first order equations. We're going to continue learning methods to compute differential equations, and today we are going to see um, yet another way to deal with our y prime equals some function of x, y, with possible initial condition of y of 0 equals y0, or whatever point we get. So it's first order, not because of Star Wars, but because it's the first derivative. So first order is first derivative only. That's what we have. First order is the first derivative only, and what we are doing here is we are going to learn a method using the integrating factor to solve this equation. So I'm going to say here the subtitle integrating factor, and you guys are going to label this as the method to solve first order differential equation. So you have separation of variables so far, and now you're adding integrating factor to the mix. Now, the way this goes is we are first going to say that our differential equation is going to be of the form dy over dx plus p of x times y equals q of x. So this is what differential equation should look like, and hopefully you will be able to use this method to solve the differential equation that looks like this. Now you are going to need integrating factor. Now it's going to put this red as well. They call it a rho of x, the Greek letter rho, equivalent to our r in Latin alphabet. And that's going to be given by e to the integral of p of x dx. And this is another formula that you absolutely must know, because you have to compute it every time when you want to solve differential equation using integrating factor. So that's what you have now to start off the problem. And the reason why we use the integrating factor and what it is, it's the fudge function, okay, that will change the formula we have, the equation we have, to the point where we can use product rule backwards, product rule from Calc 1, backwards to condense and change the formula so we can use separation of variables or integration or whatever else. So it's interesting method, and we need to just learn this trick of how to use the backwards product rule. So for this, let's start with a vanilla example, what I would call a vanilla example, and then start working with something that it's, more involved. So to learn this concept, I'm going to start at y prime equals, this is example number 4 in the book, y prime minus 2xy equal to e to the x squared. And they did not give us initial condition on this problem, so we're just looking for the general solution. Now, for this particular problem, I am going to immediately say, well, this is already in a good form. I have my p of x right here. Here's my q of x. I don't need it, but there it is. Note that I included the negative in this p of x because the original problem up there, the original formula, the form for the problem is plus px, and you have a minus in the problem. So you have to include it. We calculate the rho of x, which is the integrating factor. And that should not be a big deal for seasoned calculus players like yourself, esteemed ones. Note that I didn't put plus c. There is a reason why, in theory, that these functions can be anywhere vertically. So we just pick to be at 0. This is one of the, probably the only place ever that you would not need to put plus c. Well, you don't put plus c when you do integration by parts. Remember, when you integrate, you don't put plus c there in Calc 2. So this is another example of, very few where theory allows for no plus c. Other than that, if you have no plus c in your problem, for 99% of the cases in this course, you're just doomed. So if you like, a step-by-step breakdown, like you are, doing Macarena or whatever, your first step is to put in the same form where it's defined as, right, with a p and a q, and then isolate p. In this case, p of x is negative 2x. And then use that p in the formula for integrating factor rho to calculate integrating factor. Once you have your integrating factor, you are going to take your equation and multiply it through by integrating factor. So you're going to have your dy dx, or just y prime, minus 2xy equals e to the x squared. And you are going to multiply the entire equation by e to the negative x squared. That's your rho. So now you will have e to the negative x squared dy dx minus 2xy e to the negative x squared equals to e to the x squared times e to the negative x squared. All right, so now this is where the fun begins. This side is product rule, but it's the exploded version of the product rule. Your job is to compress it. So your entire Calc 1 was doing product rule forward, where you have the product and you find the derivative of the product. Now you are doing it backwards. You have the answer and you are compressing it into what the problem was in Calc 1. So I hope you understand that. And the answer to this is e to the negative x squared y prime when it compresses. Now don't panic yet. I will explain. And over here you have e to the 0, which is equal to 1. So those of you who do not remember product rule from Calc 1, well, first ask yourselves, why don't you remember it? Because that's one of the important concepts that we use in Calc 2 and Calc 3 and now differential equations. So evaluate your career choice, right? Um, unless it's been insane amount of time, in which case time to grind to catch up. We have uv, two functions, which gives you uv prime plus vu prime. And this is this, which clearly means then those two are that. Now, without me telling you immediately all of the pieces, where they fall in and how they fall in, I want you to stare at this and try to figure out what plugs where and how this actually worked out to be what it is. And then I'm going to work out. So I'm going to give you about 2 minutes. Huh? Okay, and now that you figured that out, the lecture is over and I will see you all next week. All right, so excellent, yes, perfect. I see in chat already that you can see that u equals e to the negative x squared and v equals y if you just compare the first term. And then you can find all of those pieces in the second term. I mean, sorry, v is equal to y prime. V prime equals y prime. That's what I wanted to say. So if you look at the first term only, you can see that u is equal to e to the negative x squared and v prime is equal to v prime. And you will always have v prime equal y prime because common sense, right? It's prime and prime. Then the second part, what's v, right? And if you are to integrate both sides, v is y. So if I label this as v, then negative 2x e to the negative x squared should be u prime. And it is, because when you differentiate e to the negative x squared, use a chain rule, there will be the derivative of negative x squared, which is negative 2x, which is this front part. So now your job is not only to memorize the formula, your job is also to learn how to compress this expression using the backwards product rule into this single expression here. And what I have now is e to the negative x squared times y prime is equal to 1. And we're almost there. I mean, how do you undo the derivative? You hit it with the integral, right? So you integrate both sides. This will kill prime. On the left-hand side, you'll just have e to the negative x squared y. And on the right-hand side, you have x plus c. You have to have this c now. It's not optional. Multiply both sides by e to the x squared. to kill it off on the left, and you have your answer. Plus c will not absorb function e to the x squared, so you have to have them both listed. And this is the general solution to your differential equation. Now, the greatest thing about differential equation as a course is your ability to check the problem provided you are not lazy. Let me repeat that. The greatest thing about this course and why 100% of the students should have the highest grades and highest marks is the ability to, if you are not lazy, check the problem by simply plugging it back into differential equation. So my differential equation was given as y prime minus 2xy equal e to the x squared. So I should be able to check this. I need y prime, which is a product rule. So copy the first, derivative of the second, plus copy the second, derivative of the first. So I need to plug this in there. I need to plug this in there and see what's up, right? If it's correct. So y prime is this long expression of e to the x squared plus 2xe to the x squared in parentheses x plus c minus 2x, and then y is given as e to the x squared x plus c, and all of that should be equal to e to the x squared. So now I realize that these two are exactly the same and they cancel each other out. I have e to the x squared equal e to the x squared, and the problem is right. So I'm a little bit confused with the chat question. You said this is in Calc 2. No, the product rule is in Calc 1. The method we are learning now is completely new. So there is no Calc 2 in this particular problem. Oh, yes. The fact that you can check differential equations and never get a wrong answer. Yeah, that's. I mean, you solve the problem wrong, and then you check and you see it's wrong, and then you redo it, and you keep redoing it until you get the right answer. That's the trick. But really, it's you know, well, if you get the wrong answer, that's fine. You know you need to redo it, so you keep working on it and practicing until you get it. See, the trick is that if you don't check, you don't know it's wrong, and that's the worst case scenario, because you are passing on your project or your I mean, it's not important, the tests and stuff like that, who cares, right? It's when you start working, you cannot send in the project that has wrong calculations for the bridge, because it's going to collapse and kill people, right? So the idea is to have multiple checkpoints and multiple, that's why we have teams, and one team checking another team, and double checking calculations and so on. These are important things. So if you guys are interested in knowing that it's correct, all you need to do is plug in and go from there. Let's see another problem. This one will be a tag spicier, problem 14, because it's going to have xy prime minus 3y. I believe this one was on the exam at one point in time even. And it has y of 1 equals to 10. So we do have the point as well. So is this in a form for integrating factor? And the answer is no, it's not. It has this x in front of y prime. And that's no bueno, right? We need y prime alone. And the way to get rid of that x is to divide everywhere by x. Now, as soon as you go and divide everywhere by x, your x is no longer allowed to be 0. Now, you know how usually it says y of 0 equals blah, blah? Now it says y of 1. So that's reflected in there as well, right? So x is not supposed to be 0. All right, what I got? I got y prime is equal, y prime minus 3y over x equal x squared. So now you look at this problem and you say, okay, my p of x in this case is negative 3 over x, right? Because your negative 3y over x is actually negative 3 over x times y. And you have your px times y in the setup of the problem. So a little bit of this algebra witchcraft to identify what your p of x is. So, oops. Now, rho of x is e to the integral of negative 3 over x dx. And this is great. I love when I get this rational function in there because it gives me ln. And that ln will cancel with e and we'll have a little bit easier time, maybe. I don't know. Let's check. Let's check what we have. So this is going to be e to the negative ln of absolute x. We don't put plus c, right? Negative 3 ln. Negative 3 ln of absolute x. So now what I'm going to do is I'm going to use that formula from pre-calculus where you push the ln inside, right? The constant inside. So if you remember, p ln x was ln x to the p. That was the formula in your all the way back in pre-calc, and you did use it in calculus as well. So this negative 3 is going to go to x over there, and we're going to get e to the ln of 1 over x cubed, because the negative pushes in the denominator, right? And then it stays positive 3. So your rho of x is just 1 over x cubed. That's all it is. And now we get our y prime minus 3y over x equal x squared, and we multiply the whole thing by 1 over x cubed. I'm going to ask you to work on it for about a minute or two. I just want to see, right, or you need to discover yourself if you are able to do that transformation with the inverse, with the backwards product rule. That's really the only scary point of this lecture, you being able to work through that thing. So try it. Maybe I should integrate some elevator music or something in these awkward silence parts where you are supposed to work this stuff out on your own. Actually, that's going to be extra feature for those who join Zoom. It's better if you follow this on Zoom than on YouTube actually live, because Zoom has no delay. I posted a link for all of you. And what do we have? We have 5 people following this on Zoom and 13 of you on YouTube. Zoom is a better option because you guys can ask questions using voice. Do not use Zoom chat. I don't see it until I shut down everything. So if you are chatting, use the YouTube chat. If you want to ask questions, you use the Zoom chat. All right, let's go with the problem. Multiply everything through. I'll get. Come on, pen. There we go. 1 over x cubed y prime minus 3y over x to the 4th equals 1 over x. Now this combines into 1 over x cubed y and equals to 1 over x. So I hope you have the same. Are we all good? So we integrate both sides. We get 1 over x cubed y equals to, and the integral over here is ln absolute x plus c. Do not drop absolute values. They're not there for decoration. You must have absolute value when you integrate 1 over x. Multiply both sides by x cubed and get y equals x cubed open parenthesis ln absolute x plus c. Again, c will not absorb x cubed. So if you're distributing, you have to have x cubed and then c times x cubed. You have to have it. If this was all just times 2, then you can just write c. You don't have to write 2c. We have a point in this problem. Y of 1 is 10. So even though this is a general solution, we can find particular solution when we say 10 is equal to 1 cubed ln 1 plus c. Ln 1 is 0. So we have c equals 10. Because ln 1 is 0, c times 1, which 1 cubed is 1, c times 1 is c, and there you go. So our problem is y equal x cubed ln x plus 10. And that would be the particular solution, which is the solution to the problem. And that's the way you use integrating factor to solve problems. Just start playing Beat Saber in the background whenever you have to work. That would be distracting. We could put some live streams if you guys want to hang out and do math. And when I run out of fuel, I can, for swinging the stuff around, I can just, stop briefly and help you with things. it will be obviously away from class time. Anyway, so this next problem will be all yours. And then we'll go from there. I'm going to pick obviously something that is terrible because, right, it's always a projection over here, you know. 1 plus x plus y plus xy and y of 0 equals 0. I have no clue how to do this, so I'm gonna try on my own. As you are struggling over there, I'm gonna be struggling and working it out myself. So let's put 5 minutes on the clock. And I just put the music on for the Zoom people. All right, let's take a look at the problem. Did you guys manage to get anywhere with it? Anyone, please? So the first part is putting in a form of y prime plus p of xy equal q of x. So we immediately see that because of this y here, these two terms have to go. And we have our y prime minus y minus xy equal to 1 plus x. See, the leftover is all in terms of x, exactly where we need it. So what do I have? I have y minus 1 plus x times y equal 1 plus x. That's when I factor y, so I can have p times y. So p of x is 1 plus x. Sorry, p of x is negative 1 plus x. Yeah, that's gonna be a that's gonna be an issue. I gotta figure these things out to be more effective. All right. So because this term here has y, that's why we had to ship these two to the left, leaving only the terms in terms of x there, because that's what we are allowed to have within Q. And once we factor out y, we got our p of x in front of y with the negative sign. And now I can finally compute rho of x, which is e to the negative integral of 1 plus x dx. And that is going to give me e to the negative x plus x squared over 2. So that's what we have. That's what we have for this. So now we multiply our differential equation by it. So we have y prime times e to the negative x plus x squared over 2 minus 1 plus x times e to the negative x plus x squared over 2 y equal 1 plus x times e to the negative x plus x squared over 2. So we multiply our differential equation by this row, and this is what we need to combine. Again, it's the term that you have, and then it's not y prime, it's just y. So e to the negative x plus x squared over 2 times y prime. And on the right-hand side, I just have this mess, 1 plus x. And it's a good mess, because it will work great once you start integrating. So it's good that it's this. So now we are supposed to integrate both sides. That's going to kill that derivative on top. And I'm going to just have e to the negative x and then plus x squared over 2 times y. So the prime is gone because derivative and integral cancel each other out. On the right hand side, I have this dx, and I use the u sub, right? Should be a dx there, right? So we use u equals negative x plus x squared over 2, which would, in a du, give me negative 1 plus x dx. So I don't have that negative, and that's what I have to fix. So we'll put the negative here and a negative here. And it becomes negative integral of e to the u du. Because this thing here is u, and all of this stuff in here, including dx, is du. It's a Calc 1 substitution. So y times e to the negative x plus x squared over 2 is equal to negative e to the u, which is negative x plus x squared over 2, plus c, because now we're integrating. At this point, we are going to divide both sides by exponential function. And they will cancel. So y equals negative 1 plus c over e to the negative x plus x squared over 2. And being this is problem 20, we had y of 0 equals 0. So we're going to plug that in. Oh, I should have done one more step. Give me one second. This is a negative exponent there, so we'll do this. So y equals negative 1 plus c times e to the x. See, this negative in denominator will push that e to the top. So this is better as a general solution right here. And now we use y of 0 equals 0 to compute c. When you plug in 0 for all of these x's, you get e to the 0, which is 1. So c is 1. And the problem is e to the x plus x squared over 2 minus 1. So this would be general solution for no, particular solution, sorry, because we calculated c. Ta-da! Right? Now, right, let's say you care and you want to check. Yes?
Why was negative 1 replaced with e to the x plus x squared over 2?
Why?
From the general to the, yeah.
Yeah, I plugged in c equals 1. Sorry, c equals 1, and that's that. And this negative 1 is... I just swapped the places so I don't have...
Okay. I understand now. My bad.
Cool. No, that's all good. That's why I'm here. I want to check this. So what's y prime? Y prime is going to be 1 plus x, that's the chain rule, e to the x plus x squared over 2, and then minus 1 is just gone. And I need to plug that into y prime is equal to 1 plus x plus y plus xy differential equation. So I have 1 plus x e to the x plus x squared over 2 should be the same as 1 plus x plus y, which is e to the x plus x squared over 2 minus 1, and then plus x times y, which is e to the x plus x squared over 2 minus 1. So is this the same? And if you are looking at mathematics in blocks, you can see that this is the same as that, which means you can factor it. So 1 plus x e to the x plus x squared over 2 should be the same as 1 plus x plus, and now you have your x squared plus, x plus x squared over 2 minus 1. That's what you're factoring, and you're left with 1 plus x. And now if you take a look at this, and this is the same, you can factor that. So you would have there we go, 1 plus x e to the x plus x squared over 2. Is that the same as if I factor 1 plus x over here? I have e to the x plus x squared over 2 minus 1. That's the first parenthesis. When I factor out here, that's what's left. And then when I factor out this one, you're left with plus 1. And now those puppies cancel, and we get true statement. So we know it's good. It's awesome. The check worked out, and we were able to show that the solution we have is correct solution. If the problem on the exam says solve and check, check gives you points. If the problem just says solve, check does not give you any points, but you should still do it because maybe you care, maybe, I don't know. So checking problems is really good. Now, due to the nature of the course, due to the nature of you need product rule and chain rule and use substitution, and guys, trust me, you do not have time to shovel through formulas and go back and forth between multiple calculus courses and stuff to try and solve your exam by, you know, utilizing stuff. You really need to know these things to have instant response, because you are going to have a timed exam at 90 minutes and it shuts down after 90 minutes. Given to the nature of the class and how terrible all of this is in terms of, you know, instruction and testing and everything, students were led to believe also over the summer that, you know, oh, we can cheat easily because I can just, you know, quickly pull up the formulas and, you know, have everything ready, and then they find that they do 4 or 5 problems out of 10 because they run out of time, because they keep looking for similar examples and so on, because they never studied. They have no clue what the hell is going on, and when they see differential equation, they don't even know which method to use. So my suggestion right now at the end of this lecture, which is 1.5, because this is the second method we learned in class, on the cover of your notebook, on that cardboard cover of your notebook, start the list, the table of methods. Separation of variables, number 1. And now you have integrating factor, number 2. In the integrating factor, you have the formula that you need, but also recognizing what those equations look like. This is not new concept to you. When you got the question on the exam 2 for a Calc 1 course, and it said differentiate the expression, it was up to you to decide whether you use basic or product rule or quotient or chain, implicit differentiation. You had a couple of methods to differentiate. You picked the proper method and solved the problem. When you jump, and you decided that by looking at what the problem looks like, and you said, okay, this one has a division, it's a quotient rule, this one has multiplication, it's a product rule, right? Function composition for chain rule. X's and Y's are mixed and I can't separate them, implicit. You categorized that stuff in your head and you were able to apply the correct rule. You did the same thing in Calculus 2 for chapter 8, where you had to categorize what the problem looks like, partial fraction decomposition, or is it integration by parts, or trig sub, right? Figuring out, you did it for sequences and series, right? Sequences and series, is it a geometric series or telescoping series or integral test? Like, what is this? Now, your entire differential equation book is going to be, again, what is the appropriate method, and then let me use the method. So it's time for you to start the list chart or something with with existing methods, so that you can use the appropriate one when the problems arise. And you will not have time to research and learn that when the test begins. So please make sure you are categorizing all of this. You are thinking about what the problems for this, and learning the form of for integrating factor of what the problems should look like, right? Because you cannot separate variables here. You cannot separate variables, and that's a problem. And that's why this problem exists. I mean, if you could solve all of the problems with separation of variables, we wouldn't have this course. There would be no need. You would just learn separation of variables in Calc 2 and be done. So this course will introduce you to 0.1% of differential equations that are there in the world. So yeah, we're gonna work 4 months on 0.1%, right? Of stuff that it's out there. So that's okay. I mean, you know, and I know 0.1% is 1,000th piece. I meant to say that. It's not a mistake, or 1% or a tenth. No, I meant to say 1,000. So 0.1%. It's a 1,000 piece, and then the entire course. Introductory course on differential equations. That's it. We'll take a 5-minute break. The Zoom people will have music on. And when we come back, 1.6 on exact equations and substitution method, which I believe ends chapter 1. Is it? Yeah. So we are going to talk about those. If we finish both the methods, then we're done. If not, we are going to finish it next class then. So 5 minutes on the clock. Music is starting for Zoom members, and then we are going to restart the stream.